running models in production where there are latency and model size constraints, a lot of the really large and performant models aren't going to work. So you end up having to really specialize the data to train much smaller models. So at Nurdle, we use LLMs to create synthetic data. So we're using fine-tuning or RAG or few-shot generation based on the specifications of the kind of content that our design partners want. So, for example, we're doing a pilot with Chris, and he was interested in complaints about banks and the different kinds of fraud that they could be committing, different intents. I can talk about this?
Yep.
Okay. Should have checked before. In a few different languages. So then we are creating synthetic data that has the text with a range of different platforms and languages, and then the intents are also labeled, the region is labeled, the bank is labeled.
We do a lot of fine-tuning of open source foundational models. And our basic premise is that smaller specialized models in open source, that when they're fine-tuned appropriately can deliver performance that is state-of-the-art, as good or almost as good as the OpenAIs and the Anthropics, at a dramatically lower cost, that are fit for purpose, and can much more easily be integrated into a company's workflow. So we have fine-tuned models from about 1 billion parameters to 7 billion, some 13 and 20, that we've actually put a whole collection out into open source. A CPU-oriented set of models, because actually if you look, it's actually a lot of times when you're doing something with sensitive data, you actually want to be able to do something on your laptop without sending sensitive company information out to a public API. When you're still trying to evaluate, is this even going to work? So we built a whole series of instruct fine-tuned models that are 1 billion parameters to 3 billion parameters that run on a laptop. So you can do RAG where all the data, all the documents, all the embeddings, everything never leaves your laptop. So we've done a lot of work with those kind of smaller LLMs, really evaluating what they can do and what they can't do.
We know that LLMs will hallucinate wildly, and so using them as a way to fact check is actually really dangerous. So instead of the generative text, what I do tend to use though is the embeddings. Specifically, I'm working on a bunch of research problems around detecting large-scale misinformation campaigns and using the embeddings to be able to link, say, different sets of claims that might be made by the same group or person, but are in different and disparate topics that might be coming out. So if you're a Russian troll farm, you may be, discussing something about, I don't know, say a volcano going off in Iceland or something like that, but you also might be talking about Trump. And, to a regular human, we wouldn't be able to really connect those. But using the embedding models, we may be able to actually group those, within a large geometric space to be able to show those a little bit better.
At Warner Bros. Discovery, with lots of video content, with video, lots of it is news and sports and entertainment. So that also comes with text. Obviously, as we are speaking, and obviously this all can be transcribed into text, and therefore you have lots of, essentially just an entire archive of text just sitting around. Not to mention lots of, if you think of movies and shows, there's lots of content that's generated online about, what were your reactions watching Game of Thrones, or, what are the plot descriptions, or, somebody publishes an article about our IP. That's a lot of text you can kind of grab from different sources. So one of the kind of very easy low-hanging fruit use cases is to describe, to have a normalized process of describing content and describing the kind of the various creative forms. Of our general philosophy to utilizing LLMs is not kind of a hands-off approach. What we're trying to deploy or trying to experiment with is to try to convert a totally manual process to a more human-machine hybrid process where the data is kind of checked and is fact-checked, and Not only that, you are using the kind of the ground truth labels to continue to train your LLMs or your other machine learning models to continue to perform better, and specifically perform better in your space, in your content space, in your data space.
At Nurdle, we're creating content and text for people that are often working on classifying user-generated content, which is a very different style from what a lot of the kind of assistant-like models were trained on. So we end up needing to fine-tune models in order to be able to create data like that, because it's just not something that we can find without fine-tuning.
A lot of the applications, not just LLMs, in general, machine learning techniques, is to introduce, a level of automation to previously, fairly manual, like, video editing or kind of text editing tasks. But if you think of like how, for example, the ChatGPT was constructed, it was really constructed to optimize this natural language feeling, like as if you're actually having a conversation with somebody, and they tend to generate lots of text. So even if it's not hallucinating, they're trying to give you like more context than it is necessary. Whereas if you're trying to introduce a level of automation, or essentially a machine learning first pass before the human verification that I had spoken about before, a lot of times these are very specific tasks. So actually using a large LLMs that tend to hallucinate or tend to give you lots of context, and also not to mention essentially very slow to run, or require very, very expensive in-house GPU resources to run. These are all infrastructural and also kind of product challenges where it's not really delivering. ChatGPT, amazing GPT-4 is generally can perform across all these tests even much better than smaller LLMs, but it's just simply not kind of cost efficient to run. So that's where we kind of start to turn to the smaller parameter models, and also the open source ones where we can, rather than using just an OpenAI API, and you're kind of sending essentially our very, very proprietary and sensitive data. Oftentimes, the creative data, essentially the rights don't belong with our company; it belongs with the creators. Those are instances where you don't really want to be sending that over essentially an open API, even with NDAs and whatever agreements are in place. So we find ourselves having to kind of host a lot of these in-house and kind of fine-tune them, and that we end up owning the models themselves as IPs, not just the data itself.
One of the important things that we need to do is we need to look at complaint data from customers on social media against, say, regulated banks. So customers might be complaining, say, that their deposits are not showing up, or their remittances from abroad aren't arriving, or their ATM are stopped working, or any of the myriad of reasons people can complain about a bank that can be indicative of something going slightly wrong. But especially when you're a small and new startup like us, that essentially would require manual tagging of every single comment, which is tens of thousands, hundreds of thousands. But so to be able to identify these things, we need things like synthetic data, like the pilot. That's why we're working with Nurdle on the pilot, so that we can train, not just LLMs, but other types of machine learning models as well, because this data is good for not just LLMs. I know they're the new hotness, but machine learning, there's a lot of other types of machine learning out there, and LLMs are one very specific part of it. So we can train these models to better recognize and classify comments that we might not have seen without having to hire a ton of people with financial knowledge, unfortunately, because you need that experience to be able to go through and tag every single one.
So what's led to so much of the dramatic improvement that we've seen, both in the big models as well as in the open source community? I think you have to say the biggest contributor to that has been data. And I think it's in three places. First, it's in the base pre-training of that model. Now, I would have been a skeptic of this, but it does seem that more is better. So base models Famously, GPT-3 and famously all the people that copied them started with 300 billion tokens of language, which seemed like an insane amount, and you'd think, do you really even need that much? But as open source models have been rolled out over the course of the last year, and they've grown to hundreds of billions of tokens, to 1 trillion, to 2 trillion, to 3 trillion, you see better out-of-the-box performance from those base models. So data is everything in the sense of it's ultimately what gives the foundational capability of the model. Second, data is everything when it comes to fine-tuning. Fine-tuning is just a data exercise. So once you have your secret recipe, you have your secret sauce, you have your secret data, you can get a model to do almost whatever behavior it is that you want if you've designed that data set the right way. So it's everything for fine-tuning. And then finally, and I'm really glad you said this, data is everything because it's your data. It's a company's data. When you really think about it, beyond the Wikipedia, interesting, kind of fun ChatGPT kinds of use cases, most of the interesting work that's going to be done with LLMs in the enterprise in one form or another is going to tie into private knowledge from that enterprise. It's your knowledge, that data, and ultimately the application of a model in an inference state to that data is really what's going to enable all the really interesting stuff with AI.
One of our big concerns at Nurdle is the license of the model that we're using. So depending on what our design partners are interested in, if it's data for fine-tuning a model or for a classifier, then as long as there's a commercial license, that's okay. But if we're creating data for someone to pre-train their own foundation model, then we have to abide by the licenses. So, can't use Llama 2 anymore in that scenario. So then we end up having to choose a few different models to work with, which of course has some stumbling blocks as you kind of try to shift your workflows between them. And so we don't have a lot of other data coming in that we have to worry about, but at Spectrum, it was exactly the opposite. We were moderating 15,000 records per second for, 6 years. Probably not that many at the beginning, that was before I joined. But we fortunately were able to keep all of that data to use that as the seed for some of our fine tuning, since it's quite a wide range of topics and languages. But for that data itself, we had it PII scrubbed before it ever touched any system that anyone at the company had access to.
The nice thing is all the data I work with everywhere is public by nature. The big difference that we have is regulatory jurisdiction and jurisdictions. So all of the work I do, actually very little of it is based stateside. But when I have to deal with the Philippines and Ghana in the same 12 hours, it gets really complicated and very expensive because they have various specific differences in their data privacy. Like one of them doesn't have one. One of them is weirdly restricted, but only around like religious things or other things like that. And so that's something that I really like synthetic data for, is because then I don't have to worry about those problems, especially when I'm testing out a hypothesis or something like that. Maybe not on the full production, but just to see if it might actually work. And then I can start calling up lawyers and various regulators and make sure that what we're doing is kosher.
So thinking about PIIs, obviously with GDPR and CCPA, which very much is the governance of consumer data. So if you're going on, your digital footprint, your purchase history, your, transaction, your biometrics, those should belong to you and they're governed kind of by you. You can, request to delete and such. But kind of the flip side of this, and I think because now we're working with LLMs, more text data, a lot of this text came from kind of, and images also, DALL-E and all these, image models. The data came from kind of creative talents. And that really brings a question about, not just who owns the data, but who owns the resulting models that are trained or fine-tuned by this data. And very importantly, who gets to profit from this. So all of this is, obviously has built through like very strict kind of governance Yeah, just kind of new challenges. I think we're thinking about generally in the industry.